Hello students, today in this session let's discuss about simple linear regression. Regression analysis is a statistical technique for investigating and estimating relationship between the variables. This is used for prediction and forecasting purpose. Applications of regression is that occurs in almost every field like social science, life and biological science, physical and chemical science, management, economics and so on. There are different types of regression techniques, namely simple linear regression, multiple linear regression, polynomial regression, non-linear regression and so on. Now let's discuss regarding simple linear regression. Before fitting linear regression model, we have to check whether there is any relationship between a set of variables. This can be achieved by making use of scatter diagram. A scatter diagram is a mathematical diagram to display values of set of variables. Now we'll go with simple linear regression model. A simple linear regression model is a model with a single regressor x that has a relationship with response variable y. A simple linear regression model is given by y is equal to beta naught plus beta 1 x plus epsilon, where y is the dependent variable, or it is also called as response variable. X is the independent variable, or it is also called as regressor. Beta naught is the intercept, beta 1 is the slope, which are unknown constant, and epsilon is the random error component, that is difference between observed value and the estimated value, where y is considered as the random variable and x is the controlled variable or deterministic variable, and beta naught and beta 1 are the parameters of the model. Now let's make assumption on simple linear regression model. Let me consider model yi is equal to beta naught plus beta 1 xi plus epsilon I, where I takes a value from 1 to n. First I have taken the model y is equal to beta naught plus beta 1 x plus epsilon, and now I have written the model as yi is equal to beta naught plus beta 1 xi plus epsilon I, which is the same model for ith observation. First assumption, epsilon I is a random variable with zero mean and unknown variance sigma square. that is expectation of epsilon I is equal to 0 and variance of epsilon I is equal to sigma square, which is unknown. Second assumption, epsilon I and epsilon j are uncorrelated, that is covariance epsilon I epsilon j is equal to 0, I not equal to j. That means the values of errors are independent. Third assumption, epsilon I is normally distributed with mean 0 and variance sigma square, that is epsilon I follows normal distribution with mean 0 and variance sigma square. By the second assumption, we have seen epsilon I and epsilon j are uncorrelated, that means they are independent. So epsilon I follows normal with mean 0 and sigma square, which is independently distributed. Given with consequency with ith observation yi follows normal distribution with mean beta naught plus beta 1 xi variance sigma square, that is consider a model y is equal to beta naught plus beta 1 x plus epsilon. Taking expectation of this model, we get expectation of y is equal to expectation of beta naught plus beta 1 x plus epsilon. I have told x is non-random variable and we know expectation of epsilon is equal to 0. So we have expectation of y equal to beta naught plus beta 1 x, and variance of y will be equal to variance of beta naught plus beta 1 x plus epsilon. X is not a random variable, and also we have seen variance of epsilon I is equal to sigma square. So variance of epsilon is equal to sigma square, that is variance of y, that is yi. The ith observation follows normal distribution with mean beta naught plus beta 1 xi and variance sigma square, which is independently distributed since y is random variable. Given a set of data, we have to check whether the data set satisfies the basic assumptions. If the data set does not satisfy the basic assumption, then there is a topic called as model adequacy checking that talks about how to check the basic assumptions are true or not. This is regarding simple linear regression, introduction to simple linear regression model. In next session, let us discuss with respect to least square estimation of the parameters and its properties. Thank you.